grade 8s, and I hope you're doing well and that you had a great start to the year and that you're on top of everything and that you perhaps have started with algebra already, or maybe you're on your way to start. But through this video, I really want to explain all the types of questions that you can get with algebraic expressions, and just to remember when you add and subtract and what to do when you multiply and divide. All right, so let's get into the questions. A question that teachers love to put into the June-July exam is a question similar to question 1. It says, consider the following expression. So if I've got, let's say, 5x squared plus 3y to the power 3 minus 6xy plus 4y squared, let's do a minus 2. All right. And then they can ask you, how many terms does this expression have? For 1 mark, that is very, very easy. Terms are separated by a plus and a minus unless they are inside brackets or unless it is part of a fraction. So let's count. We've got 1, 2, 3, 4, 5 terms altogether. Then they say write down the constant term. The constant term is the value that has no variables attached to it. So there's no x or y, anything attached to the number. So hopefully you could spot this -2 over there. So please remember the sign goes with that term. So if it was a +2, you would say +2, or just a 2. And if it was a -2 like this, you will have to include the negative, otherwise it will be wrong. Then number C, they say write down the coefficient of x squared. So then you just have to go look, where's x squared and what is the coefficient there? 5. What is the coefficient of xy? So over here, there's your xy. What is in front of it? So please remember the sign. It's not just a 6, it's a -6. Then for the y squared, what is the coefficient of y squared? A +4. Okay, then they say to determine the value of the expression if x is 2 and y is -1. So I'm going to try and squish it in here. Let's try another color. So x was 2 and y was -1. So 5 times 2 squared plus 3 times -1 to the power 3 minus 6 times 2 times -1 plus 4, and the y was a -1 squared minus 2. All right, so then let's just for now erase this, just to make some more space. There we go. Okay, then we've got 2 squared is 4, 4 times 5 is 20, plus, and then a negative raised to an odd number stays a negative, which will then be a -1 to the power 3 is 1. 1 times 1 times 1 is 1. So the only way you can drop those brackets is whatever's in front goes into the bracket. Remember, bracket exponent doesn't necessarily let the brackets fall away. The only time you can let the brackets fall away is when you multiply whatever's in front into the bracket. Goody. All right. So now, we've got a -6 times a 2 times a -1. A negative times that -1 gives you a positive. 6 times 2 times 1 gives you 12. Plus 4. So let's simplify. -1 to the power 2. A negative raised to an even number becomes a positive. And 1 squared gives you a +1. Minus 2. Then we've got 20. Plus minus is a minus. Minus 1. Plus 12. Plus 4. Minus 2. And then you are welcome just to pop that into your calculator. And just by doing that in my head, I get 33. I hope that's correct. But you're welcome to pop that into your calculator. If you're not allowed to use calculators as of yet, some schools don't, then the teacher will just normally stay more on the side of using smaller numbers than rather using these big numbers. Okay, but that was actually quite easy just to do that. So for us in our school, we can use a calculator. So for my mark allocation, it will just be 2. 1, when you replace a value, please remember you have to replace it within brackets. So 1 mark for replacing it within brackets, and the other mark is just for us. You could have popped it into your calculator if you could have, and then you could have gotten the answer. So for us, I will only allow this to count 2 marks. All right, let's quickly have a look at the difference of adding and subtracting and multiplying and dividing. So with multiplying and dividing, that's what we've learned right at the beginning, which we also call exponents. Okay, so not exponents. Exponents. So where we apply, and I don't know if you've done it like this, but we applied our snare. So we're first going to multiply the signs or divide the signs, then the numbers, then the E for exponent rules. Okay, with adding and subtracting, we only add and subtract like terms. What does that mean? If I've got x to the power 5 and an x to the power 4 and the x to the power 3 and an x to the power 2 and an x, none of them are like terms. None of them have exactly the same base and exactly the same exponent. So when you add and subtract, you can only add and subtract like terms. So if I've got 5x to the power of 5 plus 3x to the power of 2, minus 6, this pen is going to get a hiding, 2x squared plus, let's say, y plus x. Okay, so then we need to identify which ones are like terms. Like terms has the same base and the same exponents. And when we add and subtract, we do not touch the base and the exponent. The base and the exponent stays exactly the same. Exactly the same. That's why they have to be the same when we add and subtract them. Please take note. I had students still ask me, ma'am, like, can I add 5 plus x in grade, what was it? I think it was grade 9 today. And I said, are they like terms? What do you mean, ma'am? No, I don't know. Are they like terms? Anyway, so you still get questions like that. So please, your algebra knowledge and your foundation must be very, very sturdy. All right. So the ones that are like terms is this one and this one. Can you see why? Because they've got the same base. Oh, I'm trying to highlight and then it just keeps on taking it away. Got the same base and the same exponent. I'm going to try one last time. There we go. Okay. So 5 of those minus 6 of those. 5 minus 6 is a negative 1 of those. Okay, so 5 of the x to the power 5s minus 6 of the x to the power 5s gives you negative 1 x to the power 5. If you want to, you can pop it in your calculator just to make sure. You can just leave the term, the x to the power 5 out. 5 minus 6 gives you negative 1, and then go replace the x5 into your answer. The other two, there's a positive 3x to the power 2 minus 2x to the power 2. 3 minus 2 is a positive 1x squared. Okay, you don't have to write that one. Again, also over here, you don't have to write that one. But if you do, it's okay. And then the plus y and the plus x don't have any friends to add or subtract to, so they just come down in your answer. Okay, now when we multiply and divide, I'm going to take this exactly the same sum. I might just run out of space halfway through and then go over to the next line. 5x to the power 5 plus 3, I said multiply, no? Multiply with 3x squared, multiply with 6x to the power 5, multiply with 2x squared, multiply with y, multiply with x. So exactly the same sum, just instead of adding and subtracting, I'm going to multiply now. So we're going to follow our snare, the signs. They're all positive, so we don't have to stress about the signs. Then the numbers. So the signs we've done, then the numbers. So the number as normal, 5 times 3 is 15 times 6 gives you, let me try again, 15 times 6, 15 times 3 is 45, is that 90? 90 times 2 is 180. Oh, I hope I'm correct. Okay, I'll check it just now. Then you've got x's and you've got a y. So you put the x's and you've got your y's. There's x to the power 5 plus 2 is 7 plus 5 is 12 plus another 2 is 13, 14, 15. Can you also get 15 x's? So it's 1. Come no. There's 1 over there. There's 2, 3, 8, 9, 10, 15. And how many y's? Just one lonely old y. All right. And that is the difference between the two. So please, when you add and subtract, you can only add and subtract like terms. What does like terms look like? Is if you've got an x to the power 5 and you've got another x to the power 5. If you've got an x to the power 4 and a 4x to the power 4. If you've got an x to the power 3 and a negative x to the power 3. If you've got an x squared and a 2 or a negative 2x squared. If you've got an x and a negative 10x. They are like terms, those buddies. All right. All right, then let's quickly look at these carefully chosen or expressions that we have to simplify. Why I chose them is because I tweaked one as I wrote it down. I tried to find a sum that is sort of an expression that's sort of similar, but something has changed, which will change your action of how to complete the simplification. So yeah. So please have a look. That's why they're written next to each other, AA, BB, because they're almost the same. There's just here and there a little tweak which changes your whole sum. All right, so let's quickly start. Multiplying first. So please remember your order of operation. It must always happen without your teacher even saying, I know when you were little in a test, the teacher will say, use BODMAS or use the order of operation to complete the following. And then you think, oh, only when she tells you, you must do it. No, it's always, always, always. So first your brackets. Then your exponent. So if you can't simplify inside the bracket, then you're going to bring in an exponent. If there's no exponent and there's a bracket, then you have to, and you can't simplify, then we're going to revert to multiplication inside. And lastly is your plus and minus. Lastly. Okay, so over here, just to make it easier for myself, I'm going to jot down brackets over there for them. And 5 times a is 5a. Plus 2 times a is 2a, and I can add them together because they are like terms. 5a plus 2a is 7a. Over here as well. So it almost looks the same, but now instead of saying 2 times a, I say 2 times b over there. 5 times a is 5a, plus 2 times b is 2b, and then you ask yourself, are they like terms? No, so that is where you will end. Okay, again, multiplication first, so my eye is drawn to over there. So I've got 4x plus 3x times 2 is 6x. Are they like terms? Yes, I can go ahead and add them together, and it gives me 10x. Over here, my eyes are drawn to the multiplication first. So 4x plus 3x times 2 is 6x. Add it together. Gives you... Why does the sum look exactly the same? Okay, you know what? Sorry. I'm going to just change this quickly. That's why. There were original brackets over here. Sorry. Just to make it a little bit different. So if they put brackets, you have to first simplify inside the brackets. 4x plus 3x is 7x. And that we're going to multiply with 2, which gives you 14x. Okay, if you look at the difference of these two, What's in front of the bracket? Only a negative that needs to be distributed. What's in front of this bracket? There's not just a negative, but a negative 2x that needs to be distributed. All right, but I can see if I can first simplify inside my brackets, which I can because they are like terms. I'm not allowed to drop my brackets yet. Why not? Because I haven't multiplied with whatever's in front into that bracket. And 3x minus 4x is a negative x. And now we can bring that negative in. Negative times a negative is a positive x. And that leaves me with negative x. Negative 2x plus 1 still leaves me with a negative 1. Right, over here, the negative 2x stays. And inside 3x minus 4x is negative x. And now we're going to multiply negative 2x with a negative x. Negative times a negative is a positive. 2 times 1 is 2. And x times x is x squared. All right, over here, the 3a to the power 2 raised to a further 3 is a to the power 6. And 3 times a6 is 3a to the power 6. Times a 3 raised to a power 3 gives you 27. A 2 times 3 is 6. And because they're multiplying, I can go ahead, even if they weren't like terms, I could have gone and multiplied them. And 3 times 27 is 81. A, keep your same base and add your exponents. All right, so multiplication, exponent rules. Over here, the same thing. But now, instead of a multiplication, I've got a plus in the middle. So 3 to the power 3 is 27. 8 to the power 6. Plus 3 to the power 3 is 27. 8 to the power 6. So it's 27 of those plus 27 of those. Can I add them? Yes, they are like terms. So 27 plus 27 is that 54. And the 8 to the power 6 stays exactly like that. All right, the next one. A negative raised to an odd number stays a negative. So this is that exponent rule where it says everything inside the bracket is raised to the power of 3. 2 to the power 3 is 8. X 2 times 3 is 6. Minus a negative raised to an even number becomes a positive. And 2 to the power 4 is 16. X to the power of 4. So we have to melt the minus and the plus together, which gives me negative 8x to the power 6 minus, it's going to come now any time, any day now. No, minus, come now. Why does it not want to? Minus 16x to the power 4. Now, minus 8x to the power 6 minus 16x to the power 4. Can I actually subtract them? No way, Jose, because they are not like terms. This one is x to the power 6 and this side is x to the power 4, so you can't. Let's look at the next one. The 2 is on the outside. X to the power 2 is 4. So 2 times that gives you 2x to the power 4 minus. And now that 4 is on the inside. So only thing that needs to happen is the two signs need to melt. The sign negative times a negative is a positive. 2x to the power 4. Are they like terms? Yippee-doo-dah. And your exposed base and exponent stays there. So 2 of those plus 2 of those gives you 4 of those. Then let's quickly look at the distribution. You take the 3 in, which gives you 3x plus 3 times 2 is 6. Over here, what is in front of the bracket? Only the negative. Okay, so where here there was a 3, over here there's only a negative that has to go in. And a negative times a positive x is a negative x. And a negative times a positive 2 gives you a negative 2. And 3 minus 2 is 1. and 1 minus x. That's where it stays. All right, over here, simplify the brackets where you can. You only do it in grade 9 where you multiply two binomials, so not yet. 3 plus 4 is 7, and that has to go into x minus 3. So that gives you 7x minus 21. Over here, I need to distribute the 4 first. I always say to the students, it's like the devil saying, come on, add that 3 and 4, add that 3 and 4. And you say, no, no, no. The 3 stays down and the 4 goes in, and a positive 4 times a negative 3 gives you a negative 12. And 3 minus 12 gives you negative 9 plus 4x. And that's where you end. Same over here. 3x plus 5x is 8x, and that goes into 2x minus 1, or gets distributed. 8x times 2x is 16x squared minus 8x. Over here, you perhaps want to say 3x plus 5x, but please don't. The 3x comes down, plus 5 times 2 is 10x, and 10x squared, and a positive 5 times a negative 1 is a negative 5x. So I want to make sure, plus 10x squared minus 5x. And these two are like terms. 3 minus 5 gives you a negative 2x plus 10x squared. Okay, and that brings us to the next sort of algebraic expression questions that you can get. And that is where you've got 2 terms over 1 term. So people, you cannot, specifically look here, cannot go and cancel out like that. Okay, why is that? Just for the simple fact, if you had to try it on a sum, 10 plus 2 is 12. 12 divided by 2 is 6. So if you're just going to cancel out, you see that you're going to write the answer 10, which is totally wrong. So please, you cannot cancel out when there's 2 terms either on top, or 2 terms or 3 terms either at the bottom of a fraction. Okay, but what we can do in grade 9, we teach you how to factorize. But because you're not learning how to factorize yet, we're going to teach you another method. So you have to say 3x squared, you splitsies it. So the 3x goes under the 3x squared and also gets divided by the negative 12x. So you split it so that it divides out with both terms on top. So 3x squared divided by 3x, 3 divided by 3 is 1, x squared divided by x is x. Then after that, you're going to do it with the second one. So a negative times a positive is a negative. 12 divided by 3 is 4, and the x and the x cancels out. And that is your answer. So just to show you what I in actual fact did without writing it because I'm lazy, 12x over 3x. So that 3x splits, divides there and over there, and that will give you the same as that answer over there. So if you can do it just without splitting it and writing it all down, you can just go ahead and say, well, if you take those 2 and you divide it out, and you get that. So the purple one, 9 divided by 3 is 3. M to the power 9 divided by, m to the power 9 divided by m to the power 3. Keep your same base and you subtract your exponents. 9 minus 3 is 6. Then the negative times a positive is a negative. 3 divided by 3 is 1. M to the power 3 divided by m to the power 3 is also 1. 1 times 1 is 1 over there. Okay, what do I do over here? I need to first and always get rid of my brackets. So if I multiply that in, it will become 3d to the power 7 minus 3 times 2 is 6d to the power oopsie, sorry, 3d to the power of 6, and I forgot the minus in there, sorry. So 3d to the power 6 divided by times by d gives you that and that. Then over 9d to the power 6. So if you want to write it up to show how it's splitting, you can do it like that. And you do them separately. 3 over 9 simplified is 1 over 3. And d to the power 7 divided by d to the power 6 gives you 1d. Where did your power lie? At the top. Minus 6 over 9 is a third. No, 2/3. Sorry. And d to the power 6 divided by d to the power 6, they sort of just cancel out. Would give me 1, and 1 times 2 over 3 stays 2 over 3. And that is your answer. Okay. Last one before we look at a little bit of a harder one. So a to the power 4 plus a to the power 4. I need to simplify inside first. So one of those plus another one of those is 2 of those. And that's all raised to the power 4 over. And this is where we'll get to next. On the next is our list is how to take a square root and a cube root away. But if we just had to simplify that first, it will give us 64 8 to the power 16. You keep your same base. Oopsie. You keep your same base and you add the exponents. And that will give you 2 to the power 4 is 16. 8 to the power 4 times 4 is also 16 over this. Then I'll show you this in the next examples. But the square root of 64 is 8. 16 divided by 2 is 8. And then you can take it further after that. 16 divided by 8 is 2. And a to the power 16 minus 8 is 8. Where did my power lie? At the top. Okay, and that is your answer over there. 16 divided by 8 is 2. A to the power 8 over 1, which you can just write as 2a to the power of 8. Okay, let's quickly look at a little bit of a harder one where you had to do them separately. So I'm going to do this first. A positive 18 divided by a negative 3 is a negative 6x. Then if I take the next two and divide them out, a positive divided by a negative is a negative. 9 divided by 3 is 3. And the x and the x cancels out. Plus, if you had to do this one first, 12x divided by 4x gives you 3. 12 divided by 4 is 3. X divided by x is cancels out, which is 1. 1 times 3 is just 3. And then we're going to do that last one. 12 divided by 4 gives you, a negative 12 divided by a positive 4 is a negative. 12 divided by 4 is 3. And x squared divided by x is x. And then we're going to just add and subtract all our like terms. Minus 6x minus another 3x is minus 9x. And minus 3 plus 3 also sort of falls away, or is 0. And our answer is negative 9x. Okay, more examples of how to take a square or a cube root away when dealing with exponents. So please remember, and this is very important, especially when you get to grade 9 and you start to factorize, and you have to do the difference of two perfect squares, all things that are foreign to you probably, but please, you need to know how to do these. Okay, so you're going to square root the 25 as normal. Square root of 25 is 5. Then, if it's a square root, there's an invisible 2 there. So you're going to take the 8. So x, 8 divided by 2 is 4. And that's it. Same with the cube root. You cube root the number as normal, which is 2. X, 12. Now, inside over outside. What that means is inside over, or divide by, outside. Y, 9 divided by 3, and that gives you 2x to the power of 4, y to the power of 3. Okay, when we have to add, we do them just separately. Square root the number as normal. 9x to the power 6 divided by 2 gives you 3. Plus cube root of 27 is 3 as normal. And the variable with the exponent, you always say inside over outside. 9 divided by 3 is 3. And then can I go ahead and add them? Yes, I can, because they are like terms. And there's your final answer. Okay, so when you've got a cube root over an addition, you have to simplify inside first. It's like you're putting brackets there. Okay, and 8 of those plus 19 of those gives you 27 of those. And then you go ahead, cube root the number as normal, which is 3. X 6 divided by 3 is 2. Okay, then something that you have to note. When it's a cube root, we'll always give the exponents as in factors of 3. So it will be 3, either 3 or a 6. So this number over here, the exponent, will always be perfectly divisible by 3 in grade 8 and 9. Grade 10, that's a different story. Same here. So this must always be a factor of 3. Is that a multiple of 3? Sorry. Is that right? And over here as well. Okay, so can you see when it's a cube root, it will always be counted in 3s. And if you've got a square root, it will always be, this is much easier, it will always be an even number. Okay, because it should be divisible by 2. Then over here, again, an addition under a cube root. You have to complete the addition first, and then you can take the cube root away. So then you've got the cube root of 25 plus 100 is 125. M to the power 9. These two stay the same because they're like terms. You add them and then they stay like m to the power 9. Then cube root 125 is normal, which is 5. M to the power 9 divided by 3 gives you 3. Okay, multiplication, you can split it, but if you can, simplify it first. You are more than welcome to do so. But if you've got multiplication underneath, you can split the cube root between the two. So maybe after this, I'll just quickly show you the other way. So it's a multiplication. 4 plus 4 is 8 of those times by 2 to the power 3 gives you 8. X to the power 5 times 3, because the power raised to a further power you multiply together, gives you the cube root of 64, x to the power of 18. And now we can take our cube root away, which gives you 4x to the power 18 divided by 3 is 6. Okay. All right, and just to show you the other way, I just quickly did it over here. So when you multiply, you are welcome to split the cube root over the two different parts of multiplication. So I put it over this part over here, and then I put the cube root over here. Please note, a cube root, sorry, I forgot the 3 there. A cube root raised to the power 3 cancels out. It's the inverse operation of a cube is a cube root. So then what is left is just this underneath, or underneath that cube in the bracket. So when you do that, the cube root of 8 is 2, x to the power 3 divided by 3 is 1, and 2 times 2 is 4, x to the power 6. So do you see it gives you exactly the same answer? Thank you so much. I know it was a long video. Well done for watching. And I hope you understand all these types of questions, because this comprises all the types of questions that you can get in algebraic expressions. And I hope you enjoy the algebraic equations. I know the students do, because they love to find just one value. X is 10 or x is -2. So much better than all these expressions. Hey. Okay, but you must have a wonderful day, and I will see you next time. Thanks, hey, bye.